Let us check whether the given star is a binary operation or not. Our star here is defined as A star B is equal to A minus B. To show that this operation is a binary operation under R, the set of real numbers, we need to establish the closure property. The closure property tells us that after picking elements on R and subjecting it to the state operation star, which follows A minus B, if all the results will fall on the same set R, then we have established here closure property. That is an indication then, if it's true and if it will hold, that our star here is a binary operation. However, otherwise, if it will not be satisfied or the closure property will not be satisfied, then this star is not a binary operation. First, of course, we know that R is non-empty. That's very clear since R is a set of all real numbers, which includes the negatives, the positive, or we could have here, we have the range of that is negative infinity to positive infinity in interval notation, which includes fractions, integers, irrational numbers such as square roots, and all the numbers on the real number line. Since this is a non-empty, then we can pick items or elements of it which could be subjected here. If we are going to pick, let's say, 1 star 2, we'll have here 1 minus 2, which will give us negative 1, and this is an element of the real numbers. Is it now enough for us to say that this is closed or we have established the closure property? Take note that even with only one counterexample, the identity or the property of closure property will not hold. So let's try another values. Let's say if we have here square root of 3 star 1/2. These are both real numbers. We have an irrational number square root of 3 and a fraction 1/2. This is actually equal to square root of 3 minus 1/2, or you could rewrite this as 2 square root of 3 minus 1 all over 2, which is still an element of the real numbers. Now, there are a lot of examples, there are a lot of entries for real numbers, so we can just look at it differently on a contradictory part. What if we could locate a certain element on the real number which will have a result of A minus B, not an element of the real number? Let's say it's an element of an imaginary number. So let's say if we are going to pick here a certain I, which is an element of the complex numbers, okay? However, not an element of real number. We know that I can be represented as a square root of negative 1. Let's just try to see that it's acceptable here. So we have here, let's say 1 star I is equal to 1 minus I, or could be represented as 1 minus the square root of negative 1. Of course, this is no longer an element of real numbers, right? However, the I that we used earlier is in the first place not an element, okay? Not an element, sorry, element, not an element of real numbers, okay? This would mean that we can only get results for this given star that is not an element of the real numbers if we are going to include in the first place elements which are not an element of, or numbers which are not an element of real numbers, such as this. This would mean that there is no way for us to come up with resulting A minus B, which is not an element of real number, if we're only going to pick elements on the same set of real numbers. This would mean that our star here is a binary operation, since we have established that for all elements on the real number under A minus B, which is the definition of our star, closure property will hold. This means that the star here is really a binary operation under the set of real numbers. Thank you very much for watching.